Hello everyone, this is the Unit 3 review sheet by topic for Algebra 1 class, and we're going to start right now with topic number 1, function or not a function. Remember, a function is every x has its own y, every input, let me move up a little bit, every input has just its own output. All right, so when you're looking if a relation is a function, you are looking at the x's first, and if the x's repeat, like right here and here, they repeat and go to different y's, that means it is not a function. So a is out, that is not a function. Then we're going to look at the x's right here, and the 2's repeat, and it goes to -4, and 2 goes to 4. That is not a function. Every x must have its own y. So the 1's repeat here, and they go to 1 and -1. That is not allowed. D must be a function. We'll just look at the x's right now. None of the x's repeat. I don't care what's happening with the y. D is your answer. Which table represents a relationship that is not a function? Not a function. So this is not a function. The x's repeat goes to a different y. 1 can't go to 4 and 5 at the same time. This is a function. The x's don't repeat at all. This is a function. The x's don't repeat. The x's don't repeat. Not looking at the y's for B, C, or D. A is your answer. Given the relation -3, 4, 5, 8, x2, -2, 6, which value of x would make this relation a function? So if you put -3 in for x, that means -3 would be the output of 2, and a -3 can't have an output of 2 and 4, so that would be out. -1, if you put -1 in, yes, that would work. That would be a function. -2 would not be a function because there's already a -2 going to a 6, and a 5 wouldn't be good either because that 5 goes to 8 and the 5 would go to 2 as well. So B is your answer there. Which graph represents a function? I'm going to draw my vertical line test there. I'll draw my vertical line test here and here and here. So you notice that this vertical line hits 3 times, and that means the x is repeating every single time it hits more than once, and this one only hits once right here, goes through the graph once. A is the function. All the rest of them are not functions because every x has to have its own y, and they do not in B, C, and D. Which set of ordered pairs x, y is not a function? Not. So this one is not a function. There we go, right away. 3, 1 and 3, 2, not a function. If you just take a look at the rest of them, the x's do not repeat at all, and pretty easy to see that A is your function. You could cross off B, D, and C. Going to number 6, create an ordered pair that would make the relation no longer a function. I am just going to go to 4, 3. All right, 4 can't go to 2 and go to 3 at the same time, so every x has to have its own y. Remove an ordered pair that would make it a function. So I'm going to remove 3, 6. All right, that would make it a function because now 3 doesn't repeat and it's just going to 2, 3, 2. Which table represents a function? 2 repeats there, it's not a function. 1 repeats all the way with different y's, that's not a function. -3 repeats with 2 different y's, that's not a function. And -2, 0, 2, and 4 do not repeat, it is a function. And these are called mapping diagrams. And mapping diagrams, remember the x right here, the input is listed first, the x is listed first, and the input is second. So it's the same thing. If the x repeats and goes to two different y's, that means it is not a function. So you see how every x goes to a, b, and c. You could actually just highlight a, 2 goes to b, 3 goes to c. There's no repeating there. A goes to 3, b goes to 4, c goes to 4. There's no repeating there. 2 goes to 12, 4 goes to 8, 6 goes to 10. There's no repeating. 6 goes to 10 and 6 goes to 12. We'll stop right there. That is not a function. 6 can't go to 10 and go to 12 at that same time. And that's your answer. So topic number 2, linear function versus nonlinear. Remember, linear has to be y equals mx plus b. Linear has to be y equals mx plus b. Anything nonlinear is not a straight line. And remember, it's y equals x squared. Anything with an exponent next to a variable is nonlinear. Then you have y equals, let's say, 2 to the x power, right? The x can't be the variable itself. And then you could say 2 over x. That is nonlinear. Or you could say y equals square root of x is nonlinear. You could also say that y equals the absolute value of x is nonlinear. All right, so you could see a lot of those are nonlinear. So 3 to the power of x, nonlinear. This is y equals mx plus b. This is linear. This is y equals, or f of x, I should say, equals 5 to the x, 5 times x to the 4th power. As soon as you have that exponent right there next to the variable, you say it's nonlinear. The x, the variable, cannot be in the bottom of the fraction as the denominator. So this is nonlinear. And this one is linear. Just remember, when you're writing that, and you just like, if we asked you what the slope is, that, so I'll just change it to f of x equals negative x. I'm going to switch, see that negative right there? It's just confusing me. That plus 9, it's the way it's written, so I'm just switching it around. Remember, the sign of the number or variable goes with that variable. So negative x plus 9 and 9 minus x, they are the same thing. So we're going to put that over 3. Now I could identify pretty easily the slope, which is right here, right? And it's not negative x over 3. It is negative 1 over 3. So that's the slope. And the y-intercept is 9 divided by 3. 9 divided by 3 is 3. So that's what that would be, and that's why that one is linear. Which of the following sets of coordinates could not be part of a linear function? So just be careful. Let's identify functions first. So that is a function. This is a function. And this is a function. This is a function as well. So linear, we're just going to have to do the slope twice, but I'm just going to pick on this one right here. And you see how the x's like increase by 2's? So if I'm doing this one, and I'm seeing that the x increases by 2, what's the y increasing by there? This is plus 3. And then this one, while the x just continues to increase by 2, do you see that this y goes from 9 to 15? Now, I just picked this one. I didn't know the answer, but this one would be an increase of 6. There's no way that this is the actual, this is linear, which could not be a part of linear. I didn't even try the rest of them, but the way you could possibly do this and prove it without using the pattern thing that I just did was to label x1, y1, x2, y2, right? And then easily 9 minus 6, and then 4 minus 2. So you see that this is 3 over 2. Then I'm just going to do x1, y1 over here, and then x2, y2. I'm just going to leave that there. And then so I'm just going to go ahead and do y2, 9, minus y1, which is 15. And then x2, which is 4, minus x1, which is 6. So this is supposed to be, like, these slopes are supposed to be equal to each other if it's linear. If they're not equal, that means they are nonlinear. So this right here is -6, and this is -2. That slope is 3. So the slopes are different, and I proved it. I didn't have to do that, but if you want to go through the slope twice, the slopes are supposed to be the same, and if they're not the same, that means that it's not linear. So nonlinear, so this is a nonlinear function. So C is your answer. For number 3, which equation listed is linear? This is nonlinear. The exponent cannot be next to a variable and be linear. This is nonlinear. Same reason. This is linear. This is y equals mx plus b with a slope of 1/2 and a y-intercept of 0. And this is nonlinear because there's an exponent next to the variable. So out, out, out. Which one is linear? C. What are the 3 characteristics you can explain when an equation is linear? Okay, so 3 characteristics that you can explain when an equation is linear is that the first one is that it has to be in that format, y equals mx plus b. The graph of the equation is of a straight line, and also it has a constant rate of change. The slope remains the same throughout. Those 3 things, and we are on to topic number 3. So if f of x equals 1/4 x squared minus 1/2 x plus 5, what is the value of f of 6? There's a lot of different ways you can do this, but remember, this is your x. This is your input. So when you're figuring this out, and if you really want to go ahead and show some work, it is 1/4, and then every time you see x, you square it, and then 1/2 times 6 plus 5. All right, and if you could do that, then you're good. I just go ahead and pick the calculator up, and then hit y equals. I mean, it's just the easiest way for me. I'm going to put alpha x in and put 1/4. I'm putting in the whole equation in, and you see this is x squared. I'm just following the equation, minus, and then parenthesis, alpha x is, and then 1/2, and click to the right, and x, your equation should look exactly the same as the one that they gave you, which is this one right here. Now you press second function and graph. I don't even care what it looks like. But like, so they said that they're asking what's the value of the y when the x is 6. So that's basically what they're asking. So I'm going to go down to 6, and 6 is right here. And look, I didn't need to do any of the substitution. I have 6 as the input and 1 is the output. So that is your answer, and you're finished. You don't have to do anything by hand. If you needed to show work, you would show this work right here. This is the substitution. Other than that, you don't have to do anything. All right, so this is a little bit easier because it's a little bit less, it's a little bit less difficult, and there's no fractions and stuff like that. Here's h of x equals 2 times x minus 10, and I of x is x squared plus 3. So find the value of h of 4. So I'm just going to take this first, and I'm just going to put h of 4 equals, and I'm not going to go to the calculator for this because I could do 2 times 4, and this is 8 minus 10. So h of 4 equals -2. If you can't do that, though, please put it into the calculator. Now I of 3 is 3 squared, and you don't really need the parentheses because it's positive, but if it's negative, just remember you need those parentheses because you're multiplying a negative by that same negative. So for this case, it doesn't matter. This is 9 plus 3, so I 3 equals 9 plus 3, which is 12. So they're asking what h of 4, which is -2, plus the I of 3, which is 12, is equal to. Find the value. It is 10. At Benny's Cafe, a burger cost $4.75. Additional toppings could be added for 25 cents each. Which function could represent this? All right, so just remember the burger is probably what additional toppings. That's the rate that we're talking about because it's 25 cents each. So we might have a lot of toppings. So the B itself is the burger cost because that's the number that we are definitely paying without any toppings. All right, so $4.75. That should not be next to a variable. So the C of T, right, the cost is equal to $4.75 times T. No, that is not correct. $4 times T. No, I think they just subtract. I don't know what they did. The 25 cents times T, that is good, plus the $4.75 burger, that looks okay. And there's the $4 burger again. 2 is your answer. Just remember, stick with those numbers, and that's it. F of -2, just simple, really it's just substitution here. So it's 2 times -2. Again, you could put this into your calculator, the actual function into the calculator, or you could do it by hand like I'm doing right now. F of -2 equals -4 plus 6 over 2. So then F of -2 is 2 over 2, and 2 over 2 is 1. So when the x is -2, the y is 1. And that is the answer. Okay, number 5. Gina and Harold. There's a lot of words here. I work in an electronics store. Gina is paid. So Gina is paid this much plus 2% of our total sales in $X, which can be represented. Oh, they give you the equation. That's good. Harold is paid. Let me just change. Harold is paid this. And it's represented by this. Oh, that's nice. Whoa. So it says determine the value of X in dollars that would make their weekly pay the same. And it says to create an equation to calculate what would make their weekly pay the same. So I'm just going to put, when it says the same in math, you have to kind of set up an equation and put an equal sign in the middle. So I'm going to put the names, one on the left, one on the right. Gina goes to the left, Howard goes to the right. In Gina, they said that it's g of x is equal to 225. I'm going to drop that g of x plus 0.02x. And I'm going to put an equal sign in the middle, and then I'm going to put Harold's 200 plus 0.025x. And then I'm just going to solve it, right? And when we solve it, I'm going to bring the smaller x. This is 0.25x over to the larger x. And this way, I'll be able to solve the equation. This cancels. Then I'm going to grab my calculator, 0.02. I'm just going to get out of this. Clear it. And that's the graph from before. Nice big parabola. So it's 0.02 minus 0.025. And I'm going to enter it, and you notice that I am like I brought over the actual larger to the smaller, and it's okay. All right. I didn't recognize that the 0.02 was the actual smaller of the two. But it's fine. I had a negative, and it showed up as a negative, and as soon as it showed up as a negative, I realized that I did bring the larger over to the smaller. But I'm going to continue to calculate this, and this cancels. Getting the x alone, it's 0.005x equals negative 25. Then when I go ahead and divide, so it's a negative divided by a negative. Remember, it has to come out that way because, again, it has to be positive. We're dealing with the weekly pays that are the same, so it has to be positive. Let me see. This is negative 25 divided by, let me just see what this is, negative 0.005. Let me see if I got that right. Yes, I did. And then enter. You get 5,000. And that's $5,000. And that's when their weekly pay would be the same. All right, topic number 4, table below represents total miles as a function of a number of gallons of gas that are in the tank. And we're just looking at the rate. What does the rate of change represent? So you have to be careful here. So this is what I'm going to do. To make sense of this, I'm going to just do y2 minus y1 over x2 minus x1, and I'm going to put words in, all right, because this helps me. I don't know if it's going to help you, but this is what helps me. So 240 minus 60 over 8 minus 2. So 240 minus 60 is 180 miles over 6 gallons. So I'm going to grab my calculator and just figure out 180 divided by 6. So it's now, when I'm reading this, it's 30 miles per 1 gallon. So 30 miles to the gallon. Does this represent a cost? No. The cost of each gallon of gas? No. It has nothing to do with cost. The total number of miles you could travel per gallon of gas? Yes, that's it. And then how many miles a Honda Civic could go on a full tank? No. So like that's just like basically me just making sense of it, putting words to it, and that's it. Benjamin, Layla, and John deposited this set amount here into their savings each month. The graph shows the total amount of Benjamin. This is Layla, and this is John. So they're asking for which statement is true here. So I'm just going to move this down and move my face over here because I like myself on the right. Who knows? All right, so I'm just going to go ahead. Layla and John are saving at the same rate. I'm just going to go right here and just figure out the slope here. This is 1 over 600. So the M is 600. And the B is 600. Layla and John. So Layla, X1, Y1, X2, Y2. So the M equals 1,800 minus 1,400. Y2 minus Y1 over X2 minus X1. This is 2 minus 1. So the M is 400 over 1. And it's 400. So M here for John is 400. So using it, which statement is true? Layla and John are saving at the same rate. It is 400 for Layla. John, 400. We don't have to look any further. A is your answer. All right. Benjamin is saving 500 a month. No, he's saving 600 a month. So that's false. John is saving 100 less than Layla. No, they're saving the same. Layla is saving the greatest amount. No, she's not. Benjamin is. Congratulations to Benjamin. All right, compare the rates of change of the two functions. Have the same rate of change, rate of change, rate of change, rate of change, positive rate of change. Okay, so only rate of change. So function 1 is over here. I am going to avoid those negatives. The negative, 1 negative. So we have M equals Y2 over Y1 over X2 minus X1. We have 6 over 2. 6 over 2 is 3. So function number 1 has a slope of 3. I'm going to put it right up here, right in front of my face. The value of y is 3 times the value of x. 3 times the value of x. So y equals 3 times the value of x. Increased, that's a plus, by 6. Plus 6. So m equals 3. Function 1 and 2 have the same rate of change. Congratulations. Yes, it does. Function 1 has a greater rate of change than function 2. No, that's false. Function 2 has a greater rate of change than function 1. No, that's false. Function 1 has a negative rate of change. No, it doesn't. All right, and that is that. Kelly created 2 functions. Which statement is true about the rates of change? Again, rates of change only. So we have -2. And we have, I'm going to skip those negatives there, the negative. So x2, y2. So I'm just going to put it over here for function 2. M equals 7 minus 4 and 1 minus 0. Very easy numbers to deal with. 4, 5, 6, 7. Hopefully I don't make a mistake. 3 over 1. M equals 3. So I'm going to put it right over here. M equals 3. Let's see. Function A have equal rate of changes. No, they don't. Function A have negative rates of change. No, they don't. Both of them? No. Function A have 0. No. Function B has a greater rate of change than function A. And that is correct. Greater rate of change, 3 over negative 2, the further away from 0. For number 5, Sal wants to buy pizza for lunch. There are 3 pizzerias by her house. Sam, not Sal. The price of each pizzeria is shown below. So which pizzeria charges least per slice? M equals 125. This must be from 1940. The value of the total price is 175 here for Cheesy Pizzeria. Doesn't cost this anymore. We're just going to go, look, it says 1 right here. You don't really have to do much. But I mean, I'm going through the thing, but if it says 1 is equal to that, that's the slope. That's the rate. All right. If they're all linear, obviously, if you do y2 minus y1, which is 3 minus 150 over 2 minus 1, it'll give you an m of 150. So which one is which charges least? Alfonso's. A is your answer. 2 functions are represented below. What's the difference in the rate of change between function A? What's the difference in the rate of change? So this is 35. Here's function B. This is 50. Rise. This run is 50. I'm sorry. The run is 1. The rise is 50. So it is 50. What's the difference? 50 minus 35 is 15. So 15 is the difference, and difference in the rate of change. That's it. Difference is subtraction. Which function has the least rate of change? So we're just going to put 2 points down, do rise over run. This is 100 over 5. So we're going to have m equals 100 over 5, and that means the slope is 20. This slope is 19. This, we're just going to avoid all those negatives if we can. This is y1, and let's put x2. It's very difficult when there's a table like this. So it's 1 minus, so this is m, 1 minus a negative 2. Don't forget the double negative becomes positive, positive. And then 1 minus 0. So the slope is 3. 3 over 1 is 3. The cost of house cleaning service was $40 per hour. $40 per hour is the slope, the rate, so 40. Which one is the least? C is the least. All right, topic number 5, two-way tables. All right, so a table represents the hours based on work last week by the managers and office staff and insurance company. And it's right there. The only thing missing, though, is the total. So if you are putting your totals down, you might want to, well, let's read, of all the employees. So that means you have to figure out all the employees, and you have to figure out some totals. So I'm going to add these up. This is 40. I'm going to put total here. This is 30. This is 16. Then add these all across on these rows. 15, 5. This is 28. I'm going to put T here because I have no room. 20, 28. Right? 35, 15. That's 50, 58. And then we have some 16 and 5, 6, 7. This is 86. So if we have 86 there as a total, so that it says of all the employees, that's 86. What is the approximate relative frequency of those who worked less than 30 hours? So all the employees, 86, less than 30 hours, what's the approximate relative frequency? It is 40 over 86. Put the wrong thing. It says office staff who worked less than 30 hours. office staff only, that is 35. So now you grab your calculator, you do 35. Let me just put this over here. No. Over here. No. And I put that right in my calculator, so I'm just going to go and put 0.4069, right? So if it says, what's the approximate relative frequency? So I'm just going to move this over here 2 places to the right, and I have 40.7, right? 40.7, that's the approximate relative frequency. A newspaper conducted a survey, and here it is. Do not play video games, blah, blah, blah. Which statement is true? True. There were 2,451 boys surveyed. Yes, that's true. About 19% of them do not play video games. So I'm going to figure out right now, 2,451. Do not play video games, 856. So let's see if that's true. 856 divided by 2,451. That's 34.9%. So that comes out to be 34.9%, and that is false. All right, so 2,996, so 2,996 for the girls. About 65% of them play video games. So 1,361. So now I am going to put that in the calculator. 1,361 divided by 2,996. And let's see if that comes out to be anywhere. That's 45.4%. And that is not true. So we're still not there. So there were 5,447 surveyed. 46% of them do not play video games. So do not play video games, 2,493. So let's see, 2,493 divided by everybody, 5,447. And let's see if that comes out to be anything. Oh, it's the same. Well, it's almost the same, 45.8. So that would be 45.8. And they're rounding it to the nearest whole. And that would be 46%. So that's the true one. I am not going to figure out this one. But if you did figure it out, there were 2,996 girls surveyed. 34% of them do not play video games. 1635. So if you have 1635 divided by all the girls, 2,996. That would be 55% rounded to the nearest, and they're saying 34%. That is definitely false. All right, number 3, based on the frequency table above, what percent of the students prefer hot dogs? First off, they're missing totals, so let's go ahead and put that in. We're going to have totals. I don't know why I put totals, because I said totals, whatever. All right, this is 68. This is 74. This is 58. So I just added all of these across. Got 100, so 200 is the total. Based on the frequency table, what percent of students, that's all students, so we're just going to put 200 on the bottom. Preferred hot dogs, so 58 out of 200. Grab your calculator, do 58 divided by 200, and you get 29%. It's 0.29. You move that decimal over 2 places, you get 29%. Based on the frequency table, what percentage of females preferred cheeseburgers? So just the females. So let's talk about 100 females preferred cheeseburgers. So out of the females, how many people preferred cheeseburgers? You put that into the calculator, you get 32%. 0.032 and 32%. Based on the frequency table above, what percent of the students preferred cheeseburgers? So we're going to talk about 200. How many people preferred cheeseburgers? 68. And you do 68 divided by 200, you get 0.34. And you get 34%. Let me put this in, 34. And this is 32%. Great. All right, based on the frequency table above, what percent of female students preferred hot dogs? Female students, there's 100 of them. How many of they preferred hot dogs? 24. You put that into the calculator, you get 0.24, and it is 24%. Based on the frequency table above, what percent of male students who preferred pizza? So male students, there's 100 of them, 30 of them preferred pizza. So we have, I'm sorry, I'm moving it up and down. 30 over 100 equals 0.30, and we get 30%. And that is that. All right, topic number 6, arithmetic sequence, our favorite. Given the following 3 sequences, which ones are arithmetic? So in other words, remember, you have to identify if it's adding or subtracting to get to the next term in an arithmetic sequence. So let's see what this brings us. This is a +4, this is a +4, this is a +4, and this is a +4. Is this arithmetic? Yes, it is. We'll put the check mark. This is a +16. This is a plus different. This is +80. This, no good. That's out. This is a +4. This is a +4. This is a +4. That's arithmetic. So we put 1 and 3. 1 and 3 only. B is your answer. Nice and easy question to start us off. In a sequence, the first term is 6. The common difference is 4. The sixth term of this sequence is, the formula is there. It's going to be there. So this is the formula to figure this out. And there's different ways to do this. I'll do it by hand. This is easy enough to do it that way. So when you're looking for the sixth term, though, this is a sub 6 equals a sub 1 is 6 plus the d is a common difference of 4, and then the n is 6 because that's what you're looking for. So if you put that directly into the calculator, you'll get your answer. You have 6 plus 4 times 5, and that's 26. So a sub 6 is 26. Or you can just go ahead and put the first term down as 6. The common difference is 4. So this is a sub 1. This is a sub 2. A sub 2 is 10 because it's 4. It's 14. A sub 4 is 18. A sub 5 is 22. And an a sub 6 is 26 here. So just remember, if they give you a common difference, if it's low enough, you could just go ahead and do it this way by hand. Like, it's pretty easy to do. If they ask you what the 150th term is, you have to use the formula. So you go and look up the formula on the reference sheet. And the explicit formula for the arithmetic sequence, the explicit formula is when you have the first term and the term number that you're looking for, the first term and the end term, the term number that you're looking for, plus the common difference. You could use this formula. Just look up the explicit formula for the arithmetic sequence. It'll be there, and that is it. That's what we've studied in class. All right, so number 3. The first term in the sequence is 3, so I'm just going to put a sub 1 equals 3. And the 7th term is 18, so a sub 7 is 18. Nice and easy here. A sub 1 is 3. This is how I would do it. I wouldn't do it any other way. And then just go ahead and put the 18 there. It has to be low. The jumps have to be created where it gets to 18 in 1, 2, 3, 4, 5, 6 loops. 6 jumps. So I'm going to just start with 2. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2 is not good. So I'm going to erase this. And I'm going to obviously go by 3s. All right, 3, 6, 9, 12, 15. No good. All right. So now it's not a whole number. And now there's a little bit of a problem. So I originally said there were 6 jumps, right? And like right here, we go 1, 2, 3, 4, 5, 6. So 6 jumps. So in the 6 jumps, I'm going to have to do something different here. How much? It goes from 3 to 18. So I'm just going to go ahead and maybe just subtract the 2 numbers, and 18 minus 3. So that becomes 15. And I'm going to divide it by the 6 to figure out how much this actually jumps each jump. And it's 2.5. Okay, let's see if that's correct. So if we have a plus 2.5, it's 5.5. Then we have another 2.5, 6.5, 7.5, 8. And another 2.5, 10.5. And another 2.5, you get 13. And another 2.5, and you get 15.5. And another, the final 2.5 is 18. And that works. So you could always subtract the numbers and then divide it by the number of jumps, and then you can figure out exactly how much that common difference. What's the common difference? The D equals 2.5. Okay, so sequence is defined recursively as a sub 1 equals negative 5. A sub n is negative 2 times the prior term, plus 2. So I'm going to start here. This is a sub 1 equals negative 5. Here's a sub 2, and we don't know what that is. So we have to get a sub 2 equals negative 2, I'm following the formula, times, this is times, a sub 2 minus 1. 2 minus 1 is the prior term, so I'm just going to put the negative 5 in. Plus 2. So a sub 2 is negative 2 times negative 5 is 10 plus 2 is 12. What's a sub 3? A sub 3, so a sub 2 is 12. A sub 3, we don't know what that is, but we're going to go start with that. A sub 3 equals negative 2 times 3 minus 1, a sub 2. 3 minus 1 is 2. So the a sub 2 is the prior term. We have 12 as the prior term, plus 2. So a sub 3 is negative 24 plus 2. Negative 24 plus 2 is negative 22. So a sub 3 is negative 22. And that is that right there. All right. If a sequence is defined recursively again, a sub 1 is 2. And now this is the formula. So a sub 2, we don't know what that is yet. A sub 2 equals 3 times a sub 1. This is the prior term. So a sub 2 minus 1 is a sub 1. So I'm putting 2 in for that whole thing. Minus 5. So a sub 2 is 6 minus 5 is 1. So that's 1. A sub 3 equals, all right, so a sub 3 equals 3 times the prior term, which is 1, which is a sub 2. This is 3 minus 1, that's a sub 2. A sub 2 is equal to 1. Minus 5, a sub 3 is 3 minus 5 is negative 2. So a sub 3 is negative 2. I'm going to use it. A sub 4 is going to be your answer. A sub 4 equals 3 times 4 minus 1. 4 minus 1 is a sub 3. This becomes a sub 3. That's negative 2. That's the prior term. Minus 5. A sub 4 equals negative 6 minus 5. A sub 4 is negative 11. Negative 11 is the final answer. That's a lot of fun. All right. Okay, it says graph this on there on the set of axes. Very easy. Absolute value is you just press math. You go over to num. You press 1. And then you just put x plus 2 in. And you press graph. And it's a V shape because it is an absolute value graph. Press second function, you go straight up to as much negative 10. It's a negative 10. It's a 10 by 10 graph. So as much as you can just put onto this graph. Remember, negative 10 is to the left and 8 is right here. Negative 9, 7 is right there. And then it goes down just like this. Every once in a while, you do have to check it. 0, 2. Negative 2, 0. Negative 1, 1. And that's when it turns back up. Negative 1, 1. 0, 2. And it goes up like this. And I would check to see if you have, this is 8, 10. And it is 8, 10. Very good. All right, so we're going to draw the lines nice and straight. We're going to put arrows on the ends. And this is y equals the absolute value of x plus 2 on the set of axes below. All right, so explain how the graph of the y is the absolute value of x plus 2 has changed from the absolute value of x. So if you could just take a look, the parent function is always just the absolute value of the x. It's called the parent function. You press the math and you go over to num, and you're just going to put x in, and you could see from the parent function that the red is the parent function. The blue, what happens from the red to the blue, you could explain it. It moves 2 to the left. And there it is. The graph moves, translates. Translates is another thing that we haven't done. We haven't studied yet. But translates is just a movement of a graph. And it's 2 units to the left compared to the parent function. And that's it. We're going to do the same thing here. We're going to graph this on this absolute f of x. It's the absolute value of x plus 3. The only thing I do want to show you is that with this graph, you have to make sure that the absolute value is inside and just like that, like I was trying to tell you, the absolute value of the x needs to be inside the absolute value symbols, and then the 3 is on the outside. So just be careful with that. And then this should actually move up 3 from the parent function. If you have a parent function which is just the absolute value of x, and you go ahead and you graph that, you'll see that the parent function is still at 0, 0, and the absolute value of x plus the 3 on the outside moves up 3 units. So I'm going to graph that, and then I'll come back and show you the results. You can graph that and press pause. Okay, and that is 3 units up, and that is the graph and of the absolute value of x plus 3. And the graph moves, translates 3 units up compared to the parent function. So let's go on to number 3. So this really looks difficult, but it is not. All right, so you have f of x, 12x, and the domain there that they give you is x is greater than or equal to 0, and x is less than or equal to 35. And then they give you a second one, 14 times x minus 20, and in parentheses the x minus 20 plus the 200, and the domain is x is greater than 35. So the difference in salary, it's just determine the difference in salary in dollars for an employee who works 40 hours versus one who works 32. So I'm going to just take the f of 32 first. So 32 hours falls right into this one. So right there, you're going to use f of x equals 12 times 32. Right, because the 32 falls in between, is greater than or equal to 0, and is less than or equal to 35. So you wouldn't use that second one, you would use that first one. So 12 times 32, let me just put this back up here, and we're going to clear out the graphs. 12 times 32, putting it in parentheses, is 384. So f of 32 equals 384. So F40 would clearly be greater than 35. So you're going to use that 14 times 40 minus 20. And I can make it simple for myself to actually put into the calculator. This is 14 times 20. And once you put that directly into the calculator, you should get 280. Right, so the difference, they want the difference in the two. So I realized I was doing something wrong here. I forgot about this plus 200. You see that plus 200? Yeah, don't forget about that. Yeah, because it didn't make any sense. The person working 40 hours was less. So it's like common sense kind of thing, like that stopped me. And I was making a mistake. I kind of saw it on the fly that it did not make any sense that that a person that that worked 40 hours made less than a person that worked 32 hours. So they want the difference. So I'm just going to do 480 minus 384. And 480 minus 384 is 96 hours difference. And that's it. And that's it. All right, so graph this function. It is x minus 3. You put this directly in the calculator, but just remember, inside the absolute value is the opposite of what you think it would be. So if you think it's going to move to the left 3, it is incorrect. It moves to the right 3. This is moving to the left 3 as compared to and it's not linear, as compared to the parent. And this is moving 1.5, so that's out. This one is what your graphing calculator would show if you just put it directly in, just pick the graph, and that's about it. Now it says graph the piecewise function on the set of axes below. So just remember, you're just graphing this to this for this domain, and then x is greater than or equal to 2 for this one. All right, we'll come back and we'll graph this first one, and I'll show you exactly what it looks like. So this is the absolute value of x, absolute value of x plus 4 with the plus 4 outside the absolute value symbol. Just remember that moves up 4 from the 0, 0. And we only have to graph -4 to 2. So I'm going to press second function graph, and then I'm going to go down to -4. I have to include -4 in this, and it's an or equal to, so it's going to be a closed circle. So I put that away too fast. This is -4, 8. So -4, 1, 2, 3, 4, and 8 all the way up. This is a nice big closed circle. Then the next point would be -3, 7, -2, 6, -3, 7, -2, 6, -1, 5, 0, 4, -1, 5, 0, 4, almost there, 1, 5, and 2, 6, 1, 5, 1, 2, 3, 4, 5, and 2, 6. Now 2 is the last one that I am going to graph, and it's an open circle because of this right here. You see it? All right, so I'm going to go ahead and connect my points just like that. And then I'm going to label it f of x equals the absolute value of x plus 4 with the domain of x is greater than or equal to -4 and less than 2. So that's the graph of the piecewise function that I need. Now this is linear, so it's a little bit easier, but you could still use your calculator. It's -4x plus 8. I'm just going to put this over here, and I'm going to go to this and clear it out. -4x plus 8 is what I'm graphing, and that is my line. It's negative. It goes down from left to right. It crosses at 8. So I have to graph everything that is x is greater than or equal to 2. So I'm going to start at 2. I'm starting at 2. To 0. So I'm going to do this in blue. So 2, 0 is right here. And it is a closed circle. So 2, 0, let me just check that out. 2, 0, 3, -4, 3, negative 4. 1, 2, 3, 4. And then 4, 1, 2, 3, 4. I just used the slope right there. So 3, negative 4, and then 4, negative 8. And then you can't go any further because it goes off the graph. So when you're graphing this, this starts here, right, closed circle, and then goes all the way down, and then you can put an arrow right here because it continues that way, because you're graphing greater than or equal to 2 forever, right? So this is now f of x equals negative 4x plus 8, and x is greater than or equal to 2. And you can put semicolon if you want. And that is the graph. That's the graph of the piecewise function. The graph of the function is shown on the coordinate plane below. This right here is to use the graph to answer numbers 1 through 3. And let's go see what they say. Let me just zoom out a little bit because I can't see. All right. Between which two values of the function is the function nonlinear and decreasing? So that means it has to go down, and it has to go down, and it can't be straight, right? It has to be curved. So this is a increasing, this part to this part is increasing and linear. This is increasing and non-linear. This right here, well, I'm just going to leave it, right? This m is 0. We know that. This is decreasing and nonlinear, right? Nonlinear and decreasing, it starts at 4 and goes to 6. 4 to 6, 4 is your answer. Between which two values is the function, I don't know, is the function linear and increasing? Linear and increasing, I already labeled it. It is negative 5 to negative 3. Based on the graph, determine the average rate of change from the interval x is greater than or equal to negative 3 and x is less than or equal to 1. So negative 3 to 1. So negative 3 to 1. Right? That's what it said. Yes. So I'm going to grab this point right here, negative 3 to 1, and so it's negative 3, comma 1. So this is negative 3, comma 1. That's my first point. And I have to go to 1 right here. This is 1, comma 3. So we just have to get the rate of change, x1, y1, x2, y2. M equals y2 minus y1, which is 3 minus 1. And it's like all of a sudden bothering me that I can't draw a straight line. So there it is. 3 minus 1 and 1 minus a negative 3. So that's plus plus. M equals 2 over 4. M equals a half. So all of this work that I just did over there, it's M equals a half. 1 over 2. All right, and that is it. Okay, I just moved that down, and that's how I got M is a half. All right, based on, let me see if I could put this back. I can. Based on the graph, determine the average rate of change in dollars over the interval of 2. So 2, which is here, and 4, which is here. The average rate of change. So this is 2, 60, and this is 4, 100. So I'm going to put that over here, 260, and 4, 100. And do x1, y1, x2, y2, m equals 100 minus 60 over 4 minus 2. M equals 40 over 2. M equals 20. And that is your answer, 20. Going down to number 5, another long video. Thomas took a 140-mile bus trip to visit his grandparents. His trip is outlined on the graph. Explain what might have happened in the interval between D and E. So he's starting on the bus trip. Something happened B to C. The hours go by. The miles are increasing. Then all of a sudden from D to E, they stopped for a short break because the hours are going on and the miles are staying the same. All right, so the bus stopped for a half hour to a short break or to get gas, maybe a bite to eat, but it is a half hour. It is right here, 2:30 to 3, and you're good to go. State the interval in which the bus traveled the fastest. So just looking at traveling the fastest from A to B, that they averaged 20 miles, but it's a half hour. So it's 20 miles for a half hour. So that would be 40 miles per hour. There. From here to here, you can actually do the rise over run. So you could see that this is 1 to 2.5. So that's 1.5. And then you could say that's 20, 40, 60, 70, 80, 90. So this is 90 divided by 1.5. So I figured out that C to D is 60 miles per hour. And if you could really just take a look at C to D, it is the steepest line. So it obviously, that's the fastest rate. So that's the steepest line. I didn't have to go through all of that, but if it was, if it needed to be proved, you would say that this is the steepest line, and the steepest line is representative of the greatest slope, the greatest rate. State how many miles per hour the bus was traveling during this interval, and there we go. I just did it. This interval, the fastest interval. So you would just go ahead and put M equals 60 miles per hour during the fastest. And if they really wanted to see some work, it's 90 divided by 1.5, and that's it. So it's 90 miles that they traveled in 1.5 hours. What was the average rate of speed in miles per hour for Thomas's entire bus trip? So we're going to start at 0, 0. So I'm just taking a look at 0, 0. And then the ending coordinate is F. So we're at 4, 140. So 4, 140. And then we could figure out x1, y1, x2, y2, m equals 140 minus 0 and 4 minus 0, 140 over 4. And let's see how fast that they traveled. 140 divided by 4 is 35 miles per hour. So that average rate of speed was 35 miles per hour, and we're on to the last topic. All right, long video. Which statement is true for the function whose graph is shown? So domain, remember, is the value of all x's. The range is the value of all y's. Which statement is true? So these are just points, right? So you can't really say that it goes on forever, and the range either. So what we're going to do is just list all the coordinates down. 1, 2, 3, 4. So that's -4, -2. And then 1, 2. That's -2, -1. And then that's 0, 0. And that is 2, 1. And that is 1, 2, 3, 4, 2. Okay, so the domain, we're going to list that domain, which is true. -2, -1, no, this is out. -4, good. -2, yes. 0, yes. 2, and 4. This is true. I'm not going to check the range, but the range is not all real numbers, and it's not y, just y is less than or equal to 2. All right, so that's basically it. And we can cross these out. Find the domain and range using the inequality and interval notation. So let's talk about the inequality first. Remember that as soon as you see two numbers that are circled, that means it is in a compound inequality. I'm going to put the x in the middle. Go to the -3 on the left side. This is -3, and this is 2 on the right side. They are both closed circles, so we're just going to put a greater than or equal to -3, and x is less than or equal to 2. And that's basically it. That's domain. The interval notation for that would be a bracket and -3 and 2 with a bracket. The range would be the lowest the graph goes. Remember, this is y. And this is a compound inequality as well, because two numbers are circled. So we have the lowest the graph goes is -4. And the highest that the graph goes is 3. And again, it's greater than or equal to -4, and it is less than or equal to 3, because they're both included. The range would be -4 bracket, -4, and then +3 with another bracket. All right, find the domain and range. And again, we're going to use interval notation and inequality. All right, so we're talking about the domain. So one number is circled. So I'm just going to put x on my page, and I'm going to put that one number as 0. So just going this direction, in this direction on the x-axis forever, it is x is less than or equal to 0. The interval notation would be, again, going in this direction would be a -infinity. So that's what I'm going to put, -infinity in parentheses, and then a bracket on the 3 since it is definitely included. All right, and then it's a bracket on the 0, I'm sorry, as far as that goes, because it is we're talking about the x, we're talking about domain. So here is the range. So the range is the lowest and the highest that the graph goes. So again, we're going to put y down for the range. The lowest the graph goes is -3. So the highest the graph goes is infinity, and it's positive infinity. All right? So it is greater than or equal to -3. And I just don't like the way that is. It's greater than or equal to, right? Because it goes in an increasing, it goes increasing up all the way. And then the bracket is on -3 and a positive infinity because it goes in that direction forever. All right, find the range for the function f of x equals 3x minus 2 with the domain -3, 0, and 4. Very easy way to do this is to bring up the calculator, and we are going to put y equals in to the calculator instead of substituting 3 separate times. And then we're going to press second function graph. So for the domain of -3, we're going to have a -11. -11. For the domain of 0, we are going to have -2. A range of -2. And then of 4, the domain, the range is 10. So obviously 2 is your answer. And just like that, use the calculator. Use your calculator. Okay, so of which set of integers is included in -1, 3? So -1 is not included. So anything with -1 in is not included. So this is the answer. Done. 3 is included. That's why it's included in there. Pretty easy question. Which interval notation represents a set of all real numbers greater than 2 and less than or equal to 20? I'm going to have to put this into a an inequality. Which interval notation represents a set of all real numbers? So I'm just going to put x in the middle and then 2 and 20 on the outside. So greater than 2 and then greater than or equal to, less than or equal to. Good. All right, so this right here is what I'm looking at. So 2, 20 is in every single one. Greater than only is a parenthesis, and less than or equal to is a bracket. So we're looking for a parenthesis around 2 and a bracket around 20. Parenthesis around 2, a bracket around 20. That's good. This is not. All right, and that finishes up our 9th topic, and that is all. I hope it helped, and I'll see you next time.